Hi and Assalamualaikum. My name is Muhammad Arif Irfan bin Muhammad Zamri from class DKA4B. My metric number is 11DKA19F1007. In this video, I will explain about flakiness and elongation index test. This is the example of appropriate personal equipment during lab. Face mask is a must during pandemic. Other than that, wearing glove and lab coat, safety shoes to prevent from any incident. These are safety signage that we need to follow while in the lab. First, boots required, foods and drink prohibited, corrosive material hazard, electrical hazard, poison or toxic material. Theory of flakiness and elongation index test. Particle shape of aggregate is determined by the percentage of flaky and elongated particles contained. The presence of flaky and elongated particles are considered undesirable as this causes inherent weakness with possibilities of breaking down under heavy load. Flakiness index of aggregate is the percentage by weight of particle whose least dimension thickness is less than 3/5 of their mean dimension. This test is not applicable to size smaller than 6.3 mm. The elongation index of an aggregate is the percentage by weight of particles whose greatest dimension length is greater than 9/5 their mean dimension. This test is not applicable for size smaller than 6.3 mm. Objective for flakiness and elongation index test: to measure flakiness and elongation index of aggregate used in the construction of highway pavement and concrete structure. The apparatus that we use in this experiment are sieve size 50 mm, 37.5 mm, 28 mm, 20 mm, 14 mm, 10 mm, and 6.3 mm. And elongation index gauge, flakiness index gauge, and weighing balance. First step, sieve the sample through the sieve as specified in the table. Take a minimum of 200 pieces of each fraction to be tested and weigh them. To separate the flaky materials, gauge each fraction for thickness on a thickness gauge. The width of the slot used should be of the dimension specified in column of the table for the appropriate size of material. Weigh the flaky material passing the gauge to an accuracy of at least 0.1% of the test sample. To separate the elongated material, gauge each fraction for length on a length gauge. The width of the slot used should be of the dimension specified in column of the table for the appropriate size of material. Weight the elongated material retained on the gauge to an accuracy of a test 0.1% of the sample. These are data for flakiness index test. To get flakiness index test individual size, we use total passing over total passing plus total retain times 100. For example, we take retain on sieve 28mm. 185 over 185 plus 244 times 100, we will get 43.12. Then to calculate flakiness index for multiple size, we use the same formula, but we take total in column A 277 over 277 plus 1231 times 100, and we will get 18.37%. So the answer is 18%. These are flakiness index that we calculate before. These are data for elongation index text. So in this data, we calculate elongation index. We use the formula given: total M2 over total M2 plus total M3 times 100. For example, we take retain on sieve 28mm, M2 127 over 127 plus 300 times 100, and we get 29.74%. So for total elongation index, we take total M2 over total M2 plus total M3 times 100. So this is example for elongation index. Total M2 is 680 over 680 plus total M3 827 times 100, and we will get 45.12%. So elongation index is 45%. For this experiment, flakiness index is 18% and elongation index is 45%. The type of pavement that's suitable for this experiment were bituminous, aspartic concrete, or bituminous penetration macadam, because maximum limits of flakiness index is below than 25%.